Hello everyone, we have an equation under unit system and dimensional analysis. V equals to square root of AT plus BT plus C over D plus T, where A, B, C, D are unknown physical quantities. So we are asked to find the dimension of A, B, C, and D. V is velocity in meter per second and T is time. So according to the dimensional homogeneity, the dimension or the unit of V must be the same thing with the dimension or unit of square root of A plus T. At the same time, it must be also equals to the unit or dimension of BT, which at the same time would be equals to the dimension of C over D plus T. So let's see how we are going to do it. From the first one, we see that dimension of V must be equals to the dimension of square root of 80. This is the first one. Then this implies on the left, dimension of velocity is LT minus 1, which equals to, then this is square root, which we will take outside. Then we have the dimension of A, dimension of time, which is T, all under square root. Then dimension of A, which is unknown, under square root. Dimension of T, which is time, T. Then we have half. Then we have on left hand side, we have LT to the power of minus 1. So what we need to do, let's square both sides. If we square both sides, we are going to have L square T minus 2. If you square this side, then square this side, we have dimension of A. Square this side, we have just T. So if we make T the subroot of if we make dimension of A the subroot of the formula, so we can see that dimension of A, if you divide both sides by T, is going to be L square T minus 2 times T minus 1, which is L square T minus 3. So that's the dimension of A. Now if we come for B, then also we know that dimension of V is also equals to the dimension of BT, which implies dimension of velocity is LT to the power of minus 1. Open this bracket, we have dimension of B times dimension of time. On the left, we have LT to the power of minus 1. We have dimension of B. Dimension of T is capital T. So therefore, make dimension of B the solid of the formula. Dimension of B is now going to be LT minus 1. If we divide both sides by T, that is T to the power of minus 1, we are left with LT minus 2. So consider the dimension of B is therefore this. Then for C, if we look at C and D, they're connected. But down here, this is D and this is T. That means the dimension of D must be equal to the dimension of T. That's to say that dimension of D must equal to the dimension of T, because we can only add or subtract two quantities which has the same dimension or unit. So that implies dimension of T is T. So therefore, dimension of D is therefore T. Now we have got dimension of T. Then now it remains C. C, we are going to see. Then we will now take the left hand side, which will now say dimension of V is going to be the dimension of C over D plus T. Now this will give me the dimension of C over, now we have the dimension of D plus T, which we now know is time. It's going to be just the dimension of time. Then we have dimension of C over dimension of T, which is T. Then we know dimension of this, which is LT minus 1, which is velocity, which equals to the dimension of C over T. If we cross multiply, so we can say therefore dimension of C is going to be LT minus 1 multiplied by T. If we cross multiply, then we are going to have left out with that's L. So therefore the dimension of C is L, the dimension of D is time, the dimension of B is LT minus 2, and the dimension of A is L2T to the power of minus 3. So this is how to get the dimension of the constant A, B, C, and D in the equation V equals to square root of 2AT plus BT plus C over DT, because this is dimensionally correct. So this is the way how we are going to find the dimensions of A, B, C, and D. That's all for this video. Thank you.